Good afternoon, class. The topic for this section is the sine and cosine ratios. We just got done talking about the tangent ratio, or at least you should have if you just watched the video. And what the first topic we're going to look at is the sine ratio. Remember, these ratios, they're trigonometric ratios, which means they work for right triangles. And it's a ratio. Basically, if you remember what I was saying last video, is that if I look at a ratio of side lengths here, 15 to 20, that'd be the same thing as 3 to 4. Yeah, this is a 3, 4, 5 right triangle. But what if I'm given two other legs or two other pieces of information instead of the legs? Well, there's three ways to organize the information. I could use this side and this side. That's one way. I could use this side and this side for a ratio. That's another. And last but not least, I could use this side and this side. So there's three ways to use the sides of a right triangle in ratio form. Well, we've already looked at the legs. Today what we're looking at is the sine and cosine, which means the other two scenarios. So the first one we're going to look at is the so part of SOHCAHTOA, which, by the way, if you don't know this phrase, memorize it, love it. It will help you out with the sine, cosine, tangent. It'll tell you exactly what to do. SOHCAHTOA. So it tells me sine. All right, S, sine. O of so is opposite. H of so is hypotenuse. So it tells me right away what to set up. Sine of angle, whatever goes here, equals opposite over hypotenuse. That's the so part of SOHCAHTOA. Now, remember, just like tangent, I have to choose an angle. I'm choosing A, so I'm going to mark it. Got it marked. Yes. Now that I have it marked, it's opposite leg. Opposite leg is 15. So if I was doing the sine of A here, it's 15 over the hypotenuse. Well, the hypotenuse is always across from the right angle. That's 25 here. So the sine of A is 15 over 25, or reduced sine of A is 3 to 5. Yeah, this is a 3, 4, 5 right triangle. That ratio will always be the same, no matter what type of triangle. So again, I know I didn't put the angle here, but it's something real close to 36.9 degrees. And for that angle measure there, this ratio will always be 3 to 5. Always. It doesn't matter what lengths I put in there. 15, 25. It could be 18, 30, okay? Whatever it is, it's going to work. Yes. And if I look real quickly at sine of B, well, the sine of B is, again, opposite over hypotenuse. So in this case, when I make my mark, I'm going to erase A's here. And the opposite mark here will be 20. Across from B is 20. The hypotenuse is still 25. I reduce it, I get 4 to 5. Now this here isn't as nice because these aren't reciprocals for sine. However, the sine of A is equal to the cosine of B. Alright, we're not going to go into full details of why that happens, but it's because of the properties of this right triangle here. So, the sine of A here is opposite over hypotenuse, 3 to 5. The sine of B will be 4 to 5. Alright, let's now look at, let's do example 1. Let's practice setting up the sine ratio and maybe using it to solve problems. So, we're using so. Yeah, that's right. So, redraw that triangle. In this case, it looks just like the one I had. Unfortunately, I erased it. C, B, A. They tell me this over here is 48. They tell me this is 50. And they tell me this is 14. Alright, so the trained eye sees exactly what type of special triangle that is. The untrained eye, which hopefully none of us are, doesn't see it. But I see 7, 24, 25. Sine of A. Sine of A, sine of A, sine of A. So is sine of SOHCAHTOA. So I look at sine, S-O-H. So, opposite, O. H, hypotenuse. So opposite over hypotenuse. Opposite of A, 14 over hypotenuse, 50. So the sine of A, if I divide the top and bottom by 2, is 7 to 25. Not really surprised. I knew it was going to happen. Let's look at sine of B real quick. Sine of B, again, opposite over hypotenuse. So opposite of B, 48 over the hypotenuse, 50. Both are even, so divide top and bottom by 2. I get this to be 24 to 25. Yeah, and I know again it said find the sine of A and B. That means set it up. You're done. I don't need it in decimal form unless I say round to the 4th place. If they just say find the sine of A, give me the ratio. If they say to the 4th decimal place, punch it in a calculator, find me the 4th decimal place. Alright. Example 2. We're not using this just to find what sine of A and sine of B is. We're using this to find a length. Alright, in the next example it says find the values of the variables. These are the pictures they gave me. So they want me to find x and y. So they're not asking for everything, they're just asking for one side length. I look, well, I don't know what I'm going to use. It could be sine, it could be cosine, it could be tangent. I know we haven't looked at cosine yet, but it's one of the three, right? It could be tangent, it could be sine. Well, let's look. This is the angle I have right here, 65 degrees. I don't know what it's going to be, but I'm going to write 65 degrees down equal in a ratio over here. I look what I have. I have the opposite side and I have the hypotenuse. Opposite side and hypotenuse. So I have O and H. I look real quick. Which one has O and H? Sine has O and H. So that's the one I'm going to use. It's going to be sine of 65 degrees. Opposite, x, goes on top. Hypotenuse, 25, goes on bottom. Now that it's set up, I just solve for my variable. Where's x? Oh, top right. I have a proportion. Cross multiply. 1 times x. X. Yes. 25 times sine of 65. That's just 25 sine of 65. And again, I don't know this off the top of my head. Pull out your calculator. Punch it in. 25 sine of 65. Again, make sure you're in degrees. If you do not get the answer, 22.658. 22.658. You're going to need to see me because right now your calculator is either set up in the wrong mode or your calculator operates differently than the normal one. The ones that I have. Texas Instruments are pretty good about it. If you punch in 25, sine, and then your degree, you're almost always going to get it. It's when you start looking at Casios where that changes on you. Not that it's worse, it's just a different type of calculator than one I'm using. But if you do this correctly, knowing your calculator, of course, that's what you should get. Over here, I look, this is the angle I'm given. So, 47 degrees I write down equals ratio. I'm looking for y, I look at what I'm given. I'm given the opposite side, I'm given the hypotenuse. So I'm given O, I'm given H, opposite and hypotenuse. Which one has O and H in SOHCAHTOA? SOHCAHTOA. So, O and H. So, opposite and hypotenuse. I'm using sine. So, opposite goes on top, 12. Hypotenuse is y. Solve for my variable. I look. This is a proportion. Cross multiply. 12 equals y sine of 47 degrees. Oh no, what do I do here? Sine of 47 degrees is a number. If you don't believe me, punch in your calculator. Sine of 47. I get a decimal 0.73135370. It's a number. So that means I can just divide both sides by it. Divide both sides by sine of 47 degrees. Divide the side by sine of 47 degrees. So y equals 12 divided by the sine of 47 degrees. And I'm looking at this and I'm thinking, oh my, I don't know what I'm supposed to do here. Wait, this is calculator time. I take 12. I hit the divide button and I hit sine of 47 degrees. Again, if your calculator does not give you this answer, see me. But you should get 16.408. And there you go. So this is how you can use sine to solve for an unknown of a right triangle. Look, again, all I have is one side. And I have weird angles. 65 degrees, 47 degrees. These aren't ones I know off the top of my head. I know 30, 60, 90. I know 45, 45, 90. I might know 36.9, 53.1, 90 triangle. But that's a little bit less likely. So you've got to look at this and say, if I'm given one side and an angle, I now have enough to solve the triangle. Yes! Now, we've skirted around the issue. What is cosine? We have sine, we have tangent, now we're looking at cosine. It's the ka of SOHCAHTOA. It's the last ratio of the three I showed you before. The last type of side I might be given is adjacent and hypotenuse. If I'm given adjacent and hypotenuse, I don't want to have to skirt around the edge and find, the opposite side if all I'm looking for is the adjacent side. So what I'm going to have to do here is I'm going to make my right triangle. And let me just plug in the numbers that we have again. If I was doing the cosine of A here, cosine of A, make a mark. That's cosine of A. It's adjacent leg to hypotenuse. It's the ka, adjacent, hypotenuse. Adjacent goes on top. So cosine of A, the adjacent leg is 20, goes on top. Hypotenuse is always across from the right angle. In this case, it's 25. Reduce that, I get 4 to 5. Cosine of B, I plug that in real quickly. So I erase this mark and I'm looking at this one over here. The adjacent leg is now 15, so it goes on top. The hypotenuse is 25, goes on bottom. This becomes 3 to 5. No way. Yeah, this is all we have to do to find the ratio of cosine, adjacent over hypotenuse. Real quickly, let's compare this one to sine of B and this one to sine of A. So real quickly, tell me what the sine of A is and tell me what the sine of B is. As a little bit of review. Well, let's look. Sine of B. That's so opposite over hypotenuse. 20 over 25 or 4 to 5. What? Sine of A. Now, I make the mark over here. Opposite is 15 over hypotenuse 25 or 3 to 5. What? Yeah, that's right. The sine and cosine of complementary angles is the exact same number. The sine and cosine of complementary angles is the exact same number. So if this was 30 degrees and this was 60 degrees, you would get the same number across from it. The sine and cosine of complementary angles is the same ratio. That is really important. You don't necessarily use that a whole lot, but it might save you some time. Alright, so now you should be able to tell me SOHCAHTOA. You should be able to set it up any triangle using just that information up there. What I'm going to do is I'm going to erase this part up here just a little bit. I'm going to leave SOHCAHTOA because that's really important. However, that other part, you should be able to do it now without looking at the rest. We use SOHCAHTOA to help us out. So, I'll give you another problem. Find the cosine of A and cosine of B. So we're just getting practice setting up the ratio. They give me a right triangle, 14, 48, and 50. They say A is the top angle up here, B is this one over here, and C is right here. They say, hey, what's the cosine of A equal to, and what's the cosine of B equal to? So basically, find me their ratios. SOHCAHTOA, ka is cosine, that's what I'm looking for. Adjacent, hypotenuse, A and H. So A is where I'm at, adjacent leg is 48, I put it on top. The hypotenuse is 50, put it on bottom. Can I reduce that? Yeah, they're both even. Divide top and bottom by 2, I get 24 to 25. Alright, part 1 done. Cosine of B. So make a mark at B. The adjacent leg, because ka, adjacent hypotenuse, the adjacent leg is 14, so put 14 here. Hypotenuse is still 50, that hasn't changed, so put 50 here. Are they both even? Yeah, so divide top and bottom by 2, I get 7 to 25. I don't believe you can reduce that any further, so cosine of B is 7 to 25. Not horribly scary. but could be a little bit challenging. Well, let's apply this now. What if I want you to find some variables? And I gave you some angles and sine lengths again. So if you're looking at this picture here, go ahead, give it a quick shot. Alright, so let's look at the problem. I don't know which one I'm going to use, sine, cosine, or tangent. But in each case, I'm given one angle. So let's mark the angle here. We're looking at this one first. I know whatever it's going to be sine, cosine, tangent of 35 degrees. And it's going to have a ratio on the opposite side. Now I look at the information I'm given. I'm given the adjacent length to the angle, and I'm given the hypotenuse, adjacent hypotenuse, AH. And SOHCAHTOA, which one has A and H? It's the middle one, CA, which means I'm using cosine. So I put cosine right there. CA. A is first, A goes on top. That means adjacent leg goes up on top, X. The hypotenuse is second, so that means it goes on bottom, 25. I'm looking for X, so solve for X. I have a proportion, cross multiply. X equals 25 cosine of 35 degrees. Do you know this off the top of your head? Well, if you do, awesome. You're very smart. If you don't, you're just like me. Which doesn't mean you're not smart, just means you're not as smart as the people that can do it off the top of their head, I guess. But either way, we got calculators. Let's use that. X equals 20.479. Yeah, I feel pretty good. I was able to find X with knowing only one side length from the angle. Yeah. Look over here. Let's find Y. So again, I marked the angle. So 37 degrees equals a ratio, sine, cosine, or tangent. Well, let's look. I'm given the adjacent leg and the hypotenuse. So adjacent, hypotenuse, A and H, CA. Because that's SOHCAHTOA, A and H, CA. So I'm using cosine. Right away I fill in cosine over here. A is first, so it goes on top. Adjacent leg is 12. The hypotenuse is Y, goes on bottom. Now that it's set up, I solve for my variable. I have a proportion. Cross multiply. 12 times 1 is 12. Y times cosine of 37 is Y times cosine of 37. Again, I might want to hit the panic button. No! Cosine of 37 is just a number. I'm trying to solve for Y. So to get Y by itself, I'm multiplying by cosine of 37. So I have to divide by cosine of 37. Dividing both sides by cosine of 37, I get 12 divided by cosine of 37. And I get, well, when I punch this in my calculator, 12 divided by cosine of 37, I get 15.025. Yeah, I still feel pretty accomplished. Knowing only one side and one angle, I'm still able to find it. Yeah, that's pretty impressive. Alright, that's still not the only examples that we have. Because sometimes we have to mix them. Sometimes we're given real life problems. Sometimes it's not just like this and say solve for a variable. Sometimes we have to use this up here. So, in those situations, we don't just say generic angles. We say angle of elevation and angle of depression. In the last video, I gave you a little bit of introduction to angle of elevation. Basically, angle of elevation is the angle measured from the horizontal that rises. So it's an angle that's upward. So in this case here, 37 would be an angle of elevation. Because it rises from the horizontal. EF is horizontal. 35 degrees rises the side, the hypotenuse, 35 degrees, angle of elevation. Angle of depression would be like 37 over here because it brings from horizontal and we go downward. It sinks the side. That's why it's called depression. So, angle of elevation from horizontal up. Angle of depression from horizontal down. So, what if I gave you something like this? The angle of elevation for a ramp is 5 degrees. The ramp is 18 feet long. What is the height of the ramp? What? Did they give me a picture? What? They didn't? That means I have to draw one. So let's think here. The angle of elevation. Angle of elevation. Oh, that's an angle from horizontal that goes upward. Okay. So I have an angle of elevation. It's 5 degrees. All right. It's definitely not to scale because 5 degrees is a lot thinner than that. The ramp is 18 feet long. The ramp is 18 feet long. Does that mean the bottom here is 18, or does that mean the top part is 18? Well, if I'm thinking of this, the ramp is 18 feet long, that makes me think of where I'd actually walk on the ramp, which would be the top part. I'm not going to walk through the cement. This would be where 18 feet is. How tall is this ramp, or what is the height of the ramp? Well, that's how far up we go over here. Oh, wait, this is a right triangle. I'm given an angle and a side length, and I asked to find another one. I'm given one side length, I'm looking for another of a right triangle. Sine, cosine, tangent, it screams it to me. So right away I write down 5 degrees, I write an equal sign, ratio. It's a trigonometric ratio. I always butcher that word, and I don't know why. But trigonometric ratio. Is it sine, cosine, or tangent? Well, SOHCAHTOA. Let's look. This is the angle. I have the across side. So across. Well, I really shouldn't call it across because that might be confused. I have opposite. The opposite side. So it's not cosine. Not cosine. I have the opposite and I have the hypotenuse. Well, it can't be TOA because that doesn't have H. So it has to be sine. Sine, right away, write it down. So O is up first, so O goes on top. O is X. Opposite leg. H is the last letter. So that goes on bottom. 18. I have a portion. If it doesn't look like 1, add a 1 underneath. Cross multiply. I get X equals 18 sine of 5 degrees. If you can do this in your head, again, awesome. That's pretty impressive. If you can't, you're just like me, so don't worry about it. Pull out your calculator. 18 times sine of 5. Make sure you hit all the buttons correctly, otherwise you'll get a wrong answer. If you get this answer, again, your calculator is giving you what you're supposed to. X equals 1.569, rounded, feet. There we go. That's the height of the ramp. It's 1.569 feet. Yeah, we just used a real life problem. If you're given one like this and they're going to give you a picture, draw it. If you don't draw it, you're sunk. Not trying to say angle depression here, but you can't do the problem if you don't draw a picture. Now, yeah, sometimes it's hard. What if I accidentally called this 18 down here? Yeah, you would have got a different answer. Yeah, it would have technically been wrong. But if you draw me a picture, I know where your mistake was. If you chose tangent there and you did everything else right, it's the setup part. Okay, you made a mistake there. What if you use this here, you set it up perfectly up here, but then you use cosine? Then I know where the error is. Show your work. I can help you a lot better. Plus, you can also help yourself better. All right, the last example here says, fill in all information about this triangle. So they give me a triangle and they say, solve. They don't say solve this triangle, which is essentially what they're saying. And what they mean by that is solve. They mean fill in every single piece of information you know about the triangle. So I'm going to redraw it up here to help us out, so that we have a picture to look at. So I look here. Well, the first thing I'd probably do is figure out the last angle. Let's see. 15 plus 90 plus blank. Let's call it X. Equals 180. 105 plus X equals 180. X equals 75. So this last angle here is 75 degrees. Okay. Add all the angles. Whew. That's not necessarily the tough part because you were already given an angle. Now, the next question is, which side am I going to find? It doesn't matter to me. But there's only one method of trying to solve this triangle that would be completely wrong right now. If I look at SOHCAHTOA, I have a variable for the adjacent leg of 15, and I have a variable for the hypotenuse. I'm not going to use cosine if I'm using 15. It's out. It's wrong for this case. It does not work because it's two variables. I want only one variable. So in this case, I'm going to use 15 degrees, but I'm going to choose either sine or cosine. My personal preference, I want to find the adjacent leg first. So for me, that means I have the adjacent leg and I have the opposite leg. Adjacent, opposite, adjacent, opposite. O and A. So SOHCAHTOA. O and A is TOA, tangent. So I write down tangent of 15 degrees. Opposite comes first, so 6 goes on top. Adjacent comes second, so it goes on bottom. X. I look, it's all set up. I have a proportion. Cross multiply. 6 equals x times tangent of 15. I look, I don't have x by itself. Divide both sides by tangent of 15. X equals 6 divided by tangent of 15. And at this point, again, unless you're a genius or somebody that can memorize these real easily, you're using a calculator. Tangent, 6 times tangent, my bad, 6 divided by tangent of 15. And I get 22.39 feet. And that's x. So I'm going to put 22.39 feet here. To find y, I have two options. I could use sine, I could use cosine, or I could use Pythagorean's theorem. The me that says I'd like to use Pythagorean's theorem is the one that says I don't necessarily want to use the new stuff. However, the most accurate choice here would be sine. Why sine? Well, if again I'm using 15 degrees here, and I'm using a ratio. Sine of 15. So opposite is 6. That's the number they gave me. That's not rounded. Y is what I'm looking for. All these numbers are exact. 15 was what I was given. 6 is what I'm given. Y is what I'm trying to find. I'm not using a rounded answer at all. Sine will be the best way to go here because you get less error. So, solving here, cross multiply. I get 6 equals y sine of 15 degrees. And I feel like I might have done... Nope, I haven't. I'm good. Divide both sides by sine of 15, and I get y to be 6 divided by sine of 15 degrees. And you're like, hey, Mr. H, that's just like the one over there. We got 6 divided by the tangent of 15 degrees. So can I just say that this is going to be 22.39? Well, it better not be. Because if it is 22.39, I know I did a mistake because the right angle has to be larger. So, let's punch this in. 6 divided by sine of 15, and I get 23.18. And again, this would be feet. So, 23.18 feet. And because this is what I'm looking for, I'd probably just circle that because I was asked to find all information in this drawing. Yeah, this matches up. Shortest side, smallest angle. Medium angle, medium side. Longest angle, largest side. Awesome. It all matches. Well, you should be able to use sine, cosine, tangent to find lengths of sides. Whenever you're using sine, cosine, and tangent, you're finding a side length. And if I ask you to solve a right triangle here, all I'm asking you to do is find all the information. That's saying use sine and cosine repeatedly, use all the angles of a triangle out up to 180 degrees, and you're good to go. That's all we have for you. Till next time.